Welcome to Solutions for the Marine Industry, the first in the series of CompoSIDE's industry-focused webinars. My name is John Evans. I'm technical support for CompoSIDE, and I'll be hosting with Radek. Feel free to post any questions or raise your hand during the presentation. We will go through the answers at the end. The recorded presentation will also be available on the website afterwards, along with previous introductory webinars. Let me introduce you to Radek, Managing Director and co-owner of CompoSIDE.
Hello everyone. We are going to concentrate today on the marine-specific applications of our solution, and I'd like to start with the objectives of this webinar. I hope that you're going to find it very interesting and inspiring, and hopefully it will encourage you to try our solutions at the end. Our objectives for today is to introduce you to CompoSIDE as a solution for marine industry, demonstrate the efficient marine design workflows embedded in this solution based on few live examples, and basically showcase the CompoSIDE project tools potential, which are included in really fast-tracking the design work for marine typical projects. We want to also illustrate the successful application of our solutions on the live or existing projects which have been done using these tools. The agenda for today's webinar is pretty straightforward. We are going to start with tackling the challenges and identifying. This was a part of our initial work before we start creating CompoSIDE. Then we are going to introduce you to CompoSIDE. Some of you might already have seen this, but we believe this is really important to underline the key elements of the platform. And then we'll concentrate on the core element of our webinar, which is a live walkthrough, certain interesting examples of live demonstrations of how this actually is done in CompoSIDE. And at the end of the day, we'll outline the project examples, as we just mentioned. John mentioned that we are happy for you to post questions during the webinar. Feel free to post them in the webinar form. We are going to answer them at the end. If we don't manage to answer all of them, we are going to contact you and deal this on a personal basis. Okay, so let's start with marine industry challenges. I'm sure all of you have their own challenges, and we try to identify it at the beginning before we start creating the solutions for that. And we all probably face the same problems, and those 5 challenges that we outline here are as follows. There are, in most of the projects and in marine industry, there are multiple stakeholders which are involved at any point of the projects. And this is a big challenge to deal efficiently. Of course, for most of the marine projects, there are limited time and budgets. It's always not enough time and not enough money. Complexity of the design task. Normally design complex elements of the complex structures, and this needs to be addressed, and this is a challenge for quite a lot of people in the industry. Design for manufacturing. Because of short times and limited budgets, there's no time really for optimizations from manufacturing, and you need to combine this in an efficient design workflow. So this is a challenge that's faced by the industry as well. And a big challenge we identify as well is the modification management. So it's very often that modifications and changes are coming late in the stage of the projects. Sometimes they can be quite substantial, and there needs to be a way of dealing with that. Okay, now by identifying those challenges, we were thinking about solutions, and at that time we believed that most companies dealing with the composite were facing a challenge to convert in cost-effective and efficient way their design ideas into the business plans or products. And this is where the idea emerged, and we're talking about the tools that we could put together, and this is where the CompoSIDE was born. And 4 years ago, we started developing the tool set which would be able to address those challenges. We believe it's more than just a tool set, it's a solution delivered in an accessible and scalable, cost-effective model. And this is something that we would like to introduce you now to and outline 6 key features of our application or solution, which are basically addressing those challenges. First feature, which is a key element is a basis for our application, is flexible licensing. We challenge the licensing models provided by the software suppliers. We deliver flexible subscription and user-based model, which key feature is a low entry cost. You don't need to invest a lot of your project money into the tools. You can start with very low cost. It's easily accessible and scalable. Basically, you can just sign up for application and start using it. There's a lot of features included in the subscription, which gives you a freedom of carrying on design work. And also there's a very transparent cost model for paid high value features. This gives you full control of the cost on your project, so you can base your cost of your solutions into your project budgets. You can add as many users as you want. We don't have user-based license, which is a different approach to the normal solution. So scaling, adding your partners, stakeholders to the projects is very, very easy and cost effective. There's no ties as well. We tend to be very flexible. You can sign up for 1 month using it for a very short time, but equally we encourage people to stay longer, giving discounts on the longer subscription periods. The next key feature, which is the fundamental element of Composite, is that it's been developed by composite design experts around composite methods and workflows. These were incorporated and the best practices and workflows are part of Composite. This gives a very, very intuitive and powerful environment for people to deal with advanced and easy tasks around the composite design. It doesn't mean you cannot handle other things, other materials. It's still possible, but flexibility and workflows are dedicated to composite design. This means that we've created dedicated modules like laminate design, the composite beam section design, or 3D shell and frames design, which are inherited part of a design process. There are also marine dedicated modules like YachtsCant, which allows you to handle the yacht scanning and certification requirements very efficiently. Sorry. The third feature is about centralization of the data management and data management. In our environment, data is stored in one single, secured and fully backup location, accessible from anywhere in the world with internet access, with minimum IT resources required. So this gives a very, very powerful platform for simultaneous work on the set of a consistent data, which is provided to all your partners, users that are using your environment. This data is also very easily controlled using right and permissions features which are incorporated in our platform, allowing you to manage your access of your users and data management. The fourth feature is the composite feature. The composite feature, which is around agile workflows. What is agile? We've taken this name from IT industry, where agile development is a very powerful way of managing the changes. And I think similar approach can be adopted in the structural design, meaning that the changes are treated as a normal thing. So at any point when there's a late material or geometry change, or client wants to add a new idea to the design, it's very easy to handle. This is addressing one of the main challenges of a marine industry. Okay, so in our platform, updates and changes can be incorporated very easily in almost instant, with a fraction of the time and the cost. fifth feature is about automated documentation. We all agree that reports can be very, very useful and are really important part of the projects to keep traceability, to exchange data. But equally, we also may agree that it's quite difficult to create a good reports, and there's a lot of effort going into those activities. We believe that this is not the most effective way of using the time of the design engineers, and we tackle this by providing automated report generation engine, which is incorporated in our platform. So engines can be, this engine provides the editable templates which can be used for your reporting. Most of our modules have reporting engines allowing you to create a bill of material reports, sampling certification reports, FE model reports, and so on. This is quite powerful with the features like revision and version control, giving you a full flexibility and ability to control the source of the data. As a part of this engine, we also provide a sharing with URL or standard PDF documentation generation features, which are quite useful. And lastly, the last feature, which we think is quite important, is collaboration and integration. We believe that collaboration is paramount for successful projects. With so many potential stakeholders involved in the project, this is the key element to tackle. So we provided a platform which is web-based. This enables all stakeholders, starting from designers, engineers, or manufacturing teams, or procurement team, to collaborate simultaneously in the same place, drawing from the same data and using the same assumptions and same design information. This can be also controlled, as we mentioned already, with data centralization through application and project roles. The sharing is very easy, it's very intuitive, and you don't need a lot of IT expertise to be able to do it. That's it, I think, from introduction to CompoSIDE. What we want to really summarize it is just to put those features against the challenges that we outlined at the beginning. And if you start looking at it, so basically the first multiple stakeholders challenge has been addressed by the accessibility and collaboration features, which we just discussed. The limited time and budgets have been addressed by agility, fast workflows, and affordability with our licensing model. The complexity of the design task have been addressed by the composite focus and the knowledge-based and features which allows you to retain knowledge within the platform and share it with other people involved in the projects. Design for manufacture, we've cut down the significantly amount of time needed to generate documentations like reports or laminate tables, for instance. And modifications management is being addressed by agile workflows. I hope that this was a good introduction to CompoSIDE. Right now we'll move to the other part of our presentation of this webinar, and I will hand it over to John, who is going to jump into presenting it on the real life example. It's good to talk about how good it is, but it's better to see how it works really. John.
Thanks, Radek. I'd like to present the CompoSIDE environment for those who aren't, who haven't used it before and maybe would like to know how it works. So in a typical marine project, CompoSIDE can be used efficiently in the following areas. So preliminary design, including beam and panel design in YachtsCAD. We can then move on to detailed design and advanced design, including further laminate optimization and interlinked structural component design. This can be such as beam grinches or bulkhead designs, both of which we'll have an example for. We can also generate automatic bill of materials, so we can get a very quick idea of cost and weight estimations for our product. Documentation and certification, which includes support for engineering drawings, yacht scan reports, laminar space reports, and soon section space reports. So these are all facilitated by the CompoSIDE environment. CompoSIDE is a very, very horizontal based tool. So it integrates downstream workflows and upstream workflows, works from left to right. So if we go into CompoSIDE, we can see the environment here. All of our modules are laid out along the center here, but they're also along the side here. So when we're in a module, we can easily and quickly change to a different module. We can select our different projects in the top here. So make sure you're always in the right project. And this is where we can keep all our projects, make sure they're all managed okay.
For those who are not familiar with CompoSIDE, it's worth mentioning that most of the operations are done in a web browser. You don't need to install special applications, so you can just open a web browser, log in into our platform, and have full access to all the features and functionalities.
Okay. So at the top here, we also have our support modules. So all of our information for our modules is in the tech docs. And we have wiki pages for each project, product, all your materials, everything that you need to convey information to other users about. Also, you can directly contact us through this CompoSIDE chat down the bottom. So within CompoSIDE, we have project space where we can set up our products and our project settings, so failure settings, safety factors, BOM settings, and other settings. In CMDB, we have our materials. This is where they're managed, organized, and we can select depending on the project or projects where it's used. We also have laminate tools, section tools, advanced FE tools or basic FE tools. YachtsCant, which is our main ISO or GL module. We have BOMGen, where all of our BOM factors, we can define our project, all of our laminates in our project, including quantities, costs, and weights. And then we can create reports. So for our laminates, our YachtsCant, our vessels, or our product. And this can all be edited in our dashboard.
So this was a quick introduction into the environment. We are going to use this as a basis for the examples. You're going to see John is going to use certain modules, and we're going to start with automated laminate table generation, which we thought is a very simple example, which is faced by most people in the industry to create efficiently laminate table and quantities for the documentation. So we started with a simple example, and John is going to go through that.
Okay, so in project space, we have our project and product setup. This is where we define, as I said, our safety factors, our BOM settings, anything that we need to define our project. We then have our basic inputs, so our materials. We select these and use them in material selections just to make sure we have a very select list of materials to use. We can then stack these up in laminates in lamina space. And then this is where the modular environment really comes out on its own. We can then jump from lamina space to BOMGen to define an area and then create a laminate table. So let me show you how we do it. In our environment, so we go into CMDB after we've selected our project. We can select our project materials, which I've grouped in a material selection called Revision 1 Plies. I can just easily select as many as I want and drag them in there. I've already created a laminate, so I'm going to use my deck laminate, which is here. You can see which laminate is applied by the sub-laminate. So in my base deck laminates, I have these 3 plies in the outer skin, this core, and then it's symmetrical. So I'm going to take this information, I'm going to go to my dashboard, jump straight from laminar space to BOM-gen, and then I can create my BOM. For example, in my group, I can create a surface element, which I can apply. I can use my bulkhead, and I can select my area, which is whatever I need it to be. I have a component area percentage, which is defined by the folder that it's in, and a quantity. So I can add my laminate, and then this will open. If I hide these groups, let me hide these groups so it's a little bit easier to see. I can select each ply and the area that I need it to cover. So let's say these 3 plies are 100%. So I type 100, click enter, and then I can say these UC plies are only 80% of the coverage. I select those, type in 80, and hit enter. So very quickly I can define the areas of my tapes or individual plies, and once I've done this, so I only have the tapes in the outer skin, I can click save and close, and then in my bill of materials I can see the materials and the amount of plies and the cost of each of them. I can then export this to an Excel table where I can copy and paste this into my drawing, for example. So just by right clicking on the group and click export laminate table, which I can then copy and paste in. So here is my table.
As you can see, we've exported the table in a very uniform way. So every time you update your laminate at any point of your, or even material, you can recreate this table and paste it in your drawings without worrying that the data is not consistent or quantities are not right. So there are pre-formatted data tables which really speed up the process and consistency of the design work.
As you can see, that I've also defined some other manual elements, so my bonding, any reinforcements I have, or I can import a manual beam from section space, but I won't go into that now.
Mm-hmm.
Okay, so you can see the very easy and quick workflow working between the modules. I think it's a very quick and easy way of generating a laminate table. I think you will all agree that it takes quite a lot of time if you do it all yourself by manual in Excel. So this is where CompoSIDE is very useful. It's very easy, just cutting down the amount of time that it takes to generate documentation. So let's move into YachtsCant. This is where we determine the scantling, and we will go generate a YachtsCant report as well. So YachtsCant is the preliminary design tool used for dimensioning the marine structures. As before, we have the project and product setup, where we apply our safety factors, BOM factors, and analysis settings. We can then import our topology. So this is the backbone of our structure. This divides your panels and beams into different groups, depending on where they are in the boat. This is completely up to you, very flexible. You can either have a very detailed topology or have it very basic and raw. We then have our base inputs, which we've already defined. So we have our material selection and our laminate selected. this is our initial estimation of what our laminates is going to be. And these inputs are going to be the same for each of the modules that you go through. We then have a geometry import where we define or import the beam and panel dimensions. YachtsCount then automatically checks your structural elements against the ISO or GL rules, whichever you decide, which then very quickly allows you to optimize your laminates or geometry width. You can then freely optimize your laminates or geometry by jumping back into laminar space or back into YachtsCount. So this is a really efficient and unique capability of our environment. Through this automatic updating, we can then very quickly get our final panel results and then generate some documentation. In this example, it's a YachtsCount report. So let me show you how it works. If we go into CompoSIDE, we can use this button down the bottom just to show the dashboard of your environment.
Before you jump into YachtsCount, we have to mention that material selections and laminates could be already used on the simpler or earlier part of your design, so you can reuse it, or you can build the new set of laminates or more complex design at any point, and then reuse them in the YachtsCount. So I guess that John is going to start with showing the laminates, which we are going to use in YachtsCount.
Okay, so if I show you a deck laminate, this is the one that we had before. So I have my base deck laminate, and I can choose as many sub-laminates as I wish, or I can define as many sub-laminates as I wish just by selecting them in the stack up view.
This saves a lot of time in recreating laminates. So you can build laminate family which draws from the same stack ups of plies and speed up significantly the process of checking your laminate options.
Okay, so let's jump into YachtsCount. Assuming that I've selected my materials, I've created stack ups, and so I've imported my geometry. These are very standard parameters, which I'm sure you'll all be used to. This is from an Excel import, so I can do this for the whole boat, or I can create it manually by right-clicking on whichever folder you need, creating panel or beam inside. I can then just very quickly apply my laminates. So let's say this is a whole bottom laminate. Click Save, and my initial design results will appear on the right up here. So very quickly, I've got a very good idea of my capability of my laminates. I can then play with the laminates, so I can edit the laminates by just selecting or deselecting plies, or I can add plies, add cores, or reorder the laminates depending on my results. So let's save and close this. And this will take us back into YachtsCount. So very quickly, within YachtsCount, we can play with our parameters. We can play with the geometry or the laminates.
The process automatically updates the results. So once we are back in YachtsCount, the application will know that laminate changed or material changed or whatever other elements you've changed, and will update the results. So it's instant information about your consequence of your decisions, design decisions.
Okay, so let's assume that we've defined our boat fully and we want to get a certification report out. Usually this might take a while. We have to extract all the data, put it into a report. But in CompoSIDE, we can right-click on the vessel and create a YachtsCount report. So if we name this example YachtsCount report, select the vessel and the report template. So if it's to GL or ISO, you can define the templates yourself, or you can edit our existing ones, our template ones. And then we click Save.
This collects data from the database and always takes the latest data and produces the report. Mm-hmm. This report have, as you can see, the standard layout, which can be easily altered. So you can add the chapters, you can add content like pictures and other things. You can issue those and update the data in the report at any point using the revision and issue control features that we have already there. So as you can see, in a matter of a few seconds, you have fully defined report for your certification with full, if you scroll down, that show a little bit more details with material properties, stack-up definitions, and so on and so on. So this saves you a lot of time in reporting. You can export this into the HTML and share it as a link. As you can see that you have a link which you can send to other people to watch it. They don't need to have access to CompoSIDE to access this report. Or you can export it to PDF and send it as a standard PDF.
Okay.
Okay.
So you can see that the workflow is very easy. You can jump between modules and it automatically updates. Once we have our basic panel and beam geometry defined and laminates, we can then move on to a little bit more detailed design. In this example, we're going to take a midship section analysis. We're going to use section space just to check for strength and stiffness. So we have our inputs already defined. We've optimized these laminates and materials using YachtsCANT. We can then import the geometry. So in this example, we've imported a DXF. We can assign the laminates and then design with the required amount of reinforcements to your strength or stiffness requirements. And then optimize it so we can update the laminate in laminar space. And of course, it will automatically update. So let me show you the example.
So for this exercise, we are going to use section space, which is composite section design tool, handling 2D section definition in form of thin wall section or solid section. And John is going to show you how he handles the section design based on the midship section of the yacht.
Okay, so I've broken up my different areas of the boat into certain lines and then applied the laminates already. So you can see that this is a top side laminate going down into whole bottom laminate, it's a bit thicker. And then I've got some reinforcements along the bottom here. But I need to define my deck laminates. If I create a layered section element, I can take these lines, go into the stack, and then add my laminate family. This is already defined, so I take my deck laminate and click Add. It then takes all the data in. You can see which plies is applied to the element by using the tick boxes, same as in laminar space. I can save and close this. I've already added a section load, so this is my global bending moment. I can then calculate it, and then very quickly I've got my reserve factors. I can go into the result settings and I have my axial strain. Let's say I want a compressive strain of 0.1%. I can then edit this deck laminate, which is taken for both sides. In my stack, I can edit my stack and choose a different sub-laminate. So I've already defined my reinforcements, just to save a bit of time. So I can select that, click Save, and you can see that it's updated with these extra plies. I can save and close and then calculate it again. And then I have my result settings. So I have a compressive strain of 0.1, pretty close, not bang on, but I can just do that loop again, maybe adding one more ply. So we can also take this section properties, we can calculate it with the section property tool down here. And then I can just view them very quickly, all my section properties that I need. And I can export it to Excel. So if I need to work with a spreadsheet that I already have, I can just very quickly click that and it'll export it. Okay. So let's move on to a little bit more detailed design. Maybe sometimes you might want to go a little bit further, or the section space might be okay. So in this example, I'm going to define a bulkhead, and then I'm going to generate an automatic BOM from this, so a laminate table, and it'll also add it to my vessel BOM. So as before, I have my materials and laminates, they're already defined. I can import my geometry. For this example, I'm going to import it as a step file. I can assign my laminates and tapes, and then optimize it very quickly. The same process as we did before, we can go into laminate space through FE space, and it'll automatically update. And then this documentation step is my BOM report, or I can export my laminate table for my engineering drawing. So in CompoSIDE, again, I can go back to, I don't want to save this, I can go back to my dashboard. My laminates already defined, as I already said. So FE space, and then I open my FE model.
As you can see, we are opening a fully 3D capable editor in the browser, so you can really design complex shapes and advanced features if needed. It's not a must, but those features are there, and they are readily available for you to use.
Okay, so all of this was imported as a step file. And you can see that I've selected different laminates based on the area. So my deck laminate, you can see, is all a group of surfaces with one laminate applied to it. And I've also applied my side tapes and my top tapes using rules and orientation sets that you can see here. So that is very, very quick and easy to do. And all that information is within the mesh, as well as the weight properties. So if I show you the results, I've already calculated this, so you can see that it's a good design tool to very quickly get an idea of your bulkhead laminate, the way it's going to react, and the amount of reinforcement that you need.
It's fully flexible. You can define multiple load cases, you can define multiple laminate options for your area, so you can very quickly change it and check the elements. We also develop quite comprehensive sets of results, composite specific, which are very unique in our platform. So you can check, internal forces. You can check principal strains and strength analysis based on the reserve factor and so on. So this is something which is really powerful and available as a standard feature in CompoSIDE.
Okay. So the second part of this, we've already done our design. We've defined the amount of tapes we need. We've defined the laminates. Then we need to create a BOM or a laminate report. So we can exit this and jump into BOMGen. This will automatically take the material data, the areas that are needed, straight into BOM. You can see it's updating and refreshing all the data. So in my bulkheads folder, I can view this bulkhead. it will show me my laminates which have been applied to it and the areas that have been applied to.
This automatically creates the bill of material from the FE model, which saves a lot of time and gives you ability to estimate cost and weight of your materials, including factors like usage and wastage factors, very specific for your composite processing choice or material selection. This is really powerful and unique feature, which is helping saving a lot of time and errors from the process.
So to export my laminate table, I can just right-click on the FE space model and export the laminate table. Same as before, I can just copy and paste my table to my drawing or wherever I need to.
As you can see, with one click, we have a full definition of a table with full laminates, including tapes, local reinforcement, and breakdown into the quantities and areas for each of the materials. So this is something which is very powerful set of data for the designers.
Okay, so here's just a deliverables slide. So you can see here that I've just copied and pasted it straight in. Looks pretty tidy, looks pretty neat. I like it. Okay, so we don't just do shells in FE space. We can also define this bulkhead and the surrounding structure using beams. So same as before, my materials and laminates are defined. I can import my section geometry. So for each of these sections is a section space section. I can assign my materials and laminates to that section and then import my geometry and assign the load cases, as you can see here. Analyze the results, and then I can jump back from FE space into section space, directly taking the internal loads and the reactions to very quickly design those sections to be strong enough and see the load path between them.
In many cases, it depends on how you want to idealize your structure. It's all about how many details you want to model and how much time you have. So it's going in line with the limited time and budgets and projects. If you have more time and budget, you might spend a little bit more time and model it more detailedly. But in many cases, simplified approach with beam and sections, it's enough for estimating and designing the reliable structure, saving a lot of effort and costs.
Okay. So that's the end of our live examples. We have one small design iteration. So, for example, I did a pre-study for a carbon PVC design, and then the client came back to me and said, "Oh, I want it in glass PVC to see how it impacts the cost and weight." So you can see here the weight and cost for the carbon yacht. I can then use CompoSIDE to duplicate the project and then replace the material and then update the yacht scant, update the FE models, update the BOM, and then check that it all makes sense. And then create a new report vision. Very quickly, just generating a BOM and a yacht scant report from this. So you can see that I had a 15% increase in weight, but I had a 44% decrease in cost, which the customer liked.
This is, of course, the material cost that we are talking about. This is included in a database, material database, where you can handle information like cost of the materials. It's really easy to duplicate and modify projects, giving a very powerful set of tools to check options. And we encourage our engineers to do it. It's saving a lot of time in the projects. Okay.
So now we've shown you a few ways of how CompoSIDE can be used. We've used it in a few successful projects in the past. The first one is a 116-foot luxury cruiser racer. This was used to design most of the structure, the hull scantling, the beams, and most of the advanced structural bits. So you can see the example of the bulkhead, all the main sheet structures. Okay, and so we've used it in a 100-foot yacht. This is a main sheets bulkhead. This allowed us to reduce quite a lot of weight on this yacht. For this 45-foot yacht, it's a high-performance racer, so minimizing weight is the key. We used FE to design the lifting keel structure, so the gantry that lifts the keel.
It seems that we have some technical difficulties with webinar server connection.
Okay, sorry about that. I think we had a bit of technical difficulties. So we designed a main sheet structure for this 100-foot yacht, which was quite a deadline, quite a tight deadline on this project. So very quickly managed to design most of the primary structure of this yacht. Another example is a 45-foot high-performance racing yacht. This is the lifting keel gantry. So this is optimizing the weight and the stiffness and the strength of all the components involved.
This is the example of detailed design where you can see quite complex structure being designed straight into the composite, drawing from earlier design iterations using beam elements and section design as well. So we utilize full strength of the composite environment to come up with very light structure, which can be part of a yacht in the racing as well. They need to carry on this frame with them. So the target was to minimize the weight as much as possible.
And it's not just sailing yachts we've worked with. So we've got this high performance powerboat. It has about 1,200 horsepower under the hood. This example is the grillage that supports the engines. So a very highly loaded structure, all designed with CompoSIDE. And then a bit more detailed analysis. So we check this as a deck and topsides panel just to check how it reacted under the loads. So very adaptable tool.
There are only a few examples of the projects. There are many more. There are more than 100 projects. I think more than 100 projects performed using CompoSIDE, from big yachts to small component design. And basically, we want to conclude this presentation with outlining the tangible benefits of the solution. And I hope that you've seen throughout the presentation that it's not only talking, but also it's practically in use. And we believe that using our tools, we improve significantly efficiency of the projects and reducing cost of the projects. We provide easily accessible and scalable, comprehensive set of engineering and project management tools, which helps this process. We also aim to refocus engineering resources into the high-value tasks. So we want to reduce the number of days the engineers spent on reporting and tracing data and things like that. So that's a tangible benefit that CompoSIDE brings into the marine projects and industry. And last but not least, we believe that CompoSIDE brings a powerful ability to improve quality and consistency of the deliverables with given limited time and budgets of marine specific projects. That's it, I think, from the benefits that we want to outline. And we want to maybe go into a little bit more commercial elements of our platform, so you're aware of what is available and how you can get this fantastic tool in your hands. So let's go into where it's available and how you can start with it. It's very easy. You just go into our website. You sign up for 30-day trials with full access to full features, which allows you to play with it. We provide limited number of units, which you can see how much more units you use for a typical design tasks. It's a monthly 30-day trial, which we believe gives you a full overview of the capabilities. There are two plans which are available at the moment off the shelf, so you can sign up after trial to two plans. One is dedicated for small offices, which basically gives you limited but sufficient number of units to perform basic design stuff and generating reports and bill of materials. And the other one, which is dedicated for composite engineering teams as a part of bigger teams dealing with more complex design tasks like FE modeling and things like that. Obviously, it's very flexible. You can extend the plans using top-up units. If you need more, you can add or upgrade or downgrade at any point. Please go onto our website. You'll find more information about our software and technical solutions, and also commercial options. And do not hesitate to contact us if you have any specific questions. One more thing that we wanted to really cover today is to give you an outline of how we support our product. So we believe that support is very important, important part of the product. We provide the support as a part of a platform. John mentioned already that we have an embedded chat, live chat, so you can always ping us and ask the question. You can use our support portal and ask the questions and log your problems or suggestions. We are always open to listen to our customers. We host our webinars very regularly, so this webinar is one of the first webinar of the series, but there are other webinars already available. We host and keep all the data very transparent and available to all people, so go to our website. Recording and associated files are available in the knowledge-based tech support page on our website. So we are quite proactive in supporting our customers because we believe that this is the only way to make it work. And maybe just to outline what we have, what elements you can find in our platform to find your way around. So we have comprehensive technical documentations, which is part of the platform. We have very comprehensive YouTube channel, which hosts all the tutorials, which are giving you ability to learn more about how to use CompoSIDE. These have been done by John, who is today with us. So you'll find John running those tutorials. And also we have an integrated support and knowledge-based portal where you can contact us at any point when you work. Feel free to drop us an email to support or sales. We are going to answer those inquiries very, very quickly. I think that's it for today. I hope we provided you with a set of good information, allowing you to make your mind about our software. At the moment, we would like to see whether there are any questions, and we'll go to the question and answer session. So there are a few questions already there. So the first question from Chris is how much time did the carbon PVC and e-glass PVC conversion study actually took? The first study took, maybe John, you've been preparing that, so you're going to tell us a little bit more about that. So John, can you tell us how much time did you spend on both on preparing the design and converting it into the different option?
Okay, so it was only a pre-study. It was a basic panel check, and then a midship section analysis and detailed design of the bulkhead. That initial design took me maybe a day and a half, and then with CompoSIDE, I duplicated the project, replaced the materials. So I took one carbon ply for two glass plies, checked the results, and that took me probably about 2 hours. It was very quick. Yeah.
Okay, I think that's answers this question. Let's move to the other questions. Is the cost of the material updates automatically, or should the user update the changes in the cost by himself? CMDB is a material database which we host your material data. We provide generic data with indicative pricing, and you can define your own materials, defining it together with the costs. These costs are not linked to any real costs. They are indicative generally costs which are basically kept with the materials. So it's up to the users to keep project materials up to scratch. And this is initial design tool which gives you indications, but of course, using the information from the design process, you can request the quotations using our bill of material, which gives you ability to update your material cost yourself. The next question is how.
In case of pre-studies where you're actually replacing materials, as John presented, the cost gets automatically updated. So when you generate your bill of material, obviously the costs that are reported are the ones that are allocated to the materials you're using.
That's correct, yes. Let's move another question, how to export data to a FE like Nastran. At the moment, we have a FE link module which is not available as a standard module. We linked CompoSIDE with ANSYS, but we are more than happy to hear the feedback from the market. If there are needs for other FE softwares to be linked, we will be adding this. One of the powerful feature of CompoSIDE is that we provide API, which is allowing you to link data with any other software by just committing a little bit of resources to development and to develop your own code. So this is kind of open option as well. The other question was related to geometry import. Which geometry supports? So for mid-ship section import, we use DXF. So we can import DXFs into the section space. So it allows you to create or extract certain information from any CAD software, so you can bring it there. For FE space, which is our FE and 3D geometry or 3D model module, we can import both. We can import DXF or step files, which is the neutral CAD format. Okay, there's another question about how the geometry is imported into the YOTSCAN, ISO and GL rules. Basically, we provide the standard Excel file with the formats, which are basically recognized by CompoSIDE. These files can be generated either by scripting your CAD software, and we develop for one of our customers integration with CATIA, for instance, so with automatic generation of those geometrical elements. And that's, I think, the answer to the question. And now there was a question about positioning of those panels in our platform. We developed uniform measuring system. So basically, both for ISO and GL, we input the same data. It's explained in a very explained in a Yotscant. So you have always the same coordinate systems, and basically our format, Excel format, is supporting this uniform measuring system. And so this gives flexibility for us to handle different certification societies in one application. I think that's it from most of the questions that we've seen. If there are more questions, please don't hesitate to drop us a line. We are going to answer those questions. We are here to help you to get on board and try CompoSIDE in your projects. I think that concludes our webinar today. We would like to thank you for participating, and I would like to thank you for John for preparation of this webinar and live demonstrations. I think it was very powerful. And we hope to see you next time. We are going to host the next webinar soon. You can find the invitations on our website. And stay tuned. We look forward to seeing you next time. Okay, thank you very much.
Thank you.